Welcome back, everyone. In this week, we are going to look at classes. So we are basically going to look at creating and using classes. So the objectives of this lecture are, we are going to learn about class concepts. We are going to learn how to create classes from which you can instantiate objects. We will learn about instance variables and methods to declare objects, how to instantiate objects, etc., as well as how to use this reference. So basically, okay, we are also going to look at constructors, parameterized, overloaded, etc. So let's start with classes. There are two types of classes that we can create in C#. We have a class that contains a main method and a class that does not contain a main method. So ideally, as you remember, the main method, that's the entry point of every C# program. But when you create your C# project, you might have multiple classes. However, we don't want each class to have its own method because it's one project. It must have one entry point. So the other classes that you create must not have the main method. You only have one main method for your project. Okay. Then the other classes will just specify the behavior and the state of those classes without the main method. So how do we then make those classes which do not have the main method be able to execute? We have to create their objects in the main method and then invoke those methods which are in that class so that we can execute the code in those classes. Okay. You understand this one better probably when you look at examples. But let's look at this. Ideally, when we talk of classes, if we are going to represent a class, we will have said this, and then here we have the name of the class, right, at the top. Then we have the attributes of that class or the fields of that class. We have them here at the top, and then followed by the behavior or the methods of the class, which we have here. So this is basically an abstract representation of a class. We have the fields or the state, and then we have the methods or the behavior of that class. So when you're arranging your class or when you're organizing your class, you should start with the fields and then you go down to the methods. Okay. So when we have the fields, or when we have the variables that we have inside the class outside of methods, okay, inside of a class, but outside of methods. And if those fields are not marked as static, we refer to those fields as instance variables. Remember, an object is an instance of a class. So when we have a variable like, say, maybe int age, if we have a variable like int age inside a class, but outside of any methods, what it means is this variable is an instance variable. In other words, we are saying every instance of this class will have its own value for the variable age. And then these fields that we have here, they are also called the state of an object. And I also said we can refer to these ones as the state. Okay, so we're saying fields, state, or instance variables. All right. Now let's move on to the next. All right. So when we are creating a class in C++, we have what we refer to as a class header or a class definition. So your class definition should contain three things. Firstly, we need to use the keyword class. The keyword class, it's a must to have it. It's in lowercase. So you write it as class, and then after writing class, you then specify the name of the class, right? And then you need these curly braces for your class, and then you write whatever code that you must have in there. Okay. So we have class, we have the class, we have the class, we have the keyword class, we have the name of the class, and then we have the parentheses, and then we write the code inside. Now, what I've written here, it's mandatory for every class. You need the keyword class, you need the name of the class, which is basically an identifier. The name of the class it must be a valid identifier in C#, which means it must not be a keyword, it must not contain space, it must not start with a digit, all those other rules that you remember from naming identifiers. Then this curly brace is mandatory. This curly brace, again, the closing curly brace is mandatory, but the code inside, it's not mandatory. It's optional for you to write the code or not. Though having a class that does not have any code inside does not make sense, because it basically means that the class is not doing anything. However, prior to writing class, we can also have modifiers. You can have access modifiers like a public, protected, etc. All those other access modifiers that we covered last time. Okay, so move. Then when you create a class, we can use any access modifier. You can use private, you can use protected, you can use public, you can use internal, etc. However, when you create a class with a protected access modifier or a private access modifier, it means the access to that class is limited. So ideally, we would normally use the keywords or the access modifiers public or internal. Okay. Now, when you declare a class using a namespace, you can only declare it to be public or internal. As you might have seen, when you create your Java project, when you create your C# project, and then you create a class, you realize that by default, that class will be marked as internal. Okay. So you use either public or internal when you create a class using a namespace. Now, you can create variables inside classes, like I've stated earlier on. Again, you can use any access modifiers that you can think of. You can mark a variable as public, you can mark it as protected, you can mark it as internal, private, static, read-only, etc., including volatile. Now, when you mark a variable as public, marking variables as public is not recommended, because it means any class that can access that class is able to modify the values of that class. So we don't want that to happen. So ideally, you would remember that one of the features of object-oriented programming is data hiding, okay, or encapsulation. So with encapsulation, we want to hide the state of a class. We want to hide the instance variables of a class. We want to hide whatever variables that are associated with a particular class. And then if we want to provide means of other classes accessing that variable, we can do so by providing methods known as setters and getters, or by using what are known as properties, which we shall talk about later, which we can use to set and to get values from a variable. You can also mark a variable as read-only. So when you mark a variable as read-only, you can only do this with instance variables. You cannot do that with local variables. And read-only variables can be initialized by the construct. So when you think of it this way, we have const, which we use to declare a constant. And as you remember, a constant, the value of a constant will not change throughout the execution of a program. Now, as you might also probably guess, read-only would also mean that the variable should not be modified, because we are saying it's read-only. However, there's a difference between read-only and read-only and const. The difference between them is that when you use const, the moment you declare the variable, you have to specify the value when you use const. But when you use read-only, you have an option of not specifying the value, but then the constructor will be able to initialize a read-only variable. Okay. I hope that makes sense. Then you can also create methods. Now, like I said, as far as fields are concerned, we have to make them private so that they cannot be modified by other classes without the knowledge of the class that contains them. However, we need to provide methods which will allow us to be able to provide read access or write access to those variables. So when it comes to the ideally, in object-oriented programming, we would want to make all fields private. as long as there's no inheritance involved. All fields must be marked as private, and then we can mark the methods as public. So ideally, methods should be marked as public and the fields should be marked as private. Now, if there is some inheritance involved, we can then use other modifiers like protected, etc. But under no circumstances should you mark a variable as public. Okay. So let's look at an example that we have here. We have a class called employee, and then we have an instance variable ID number, which is marked as private, and it's of type int. Why am I saying that this is an instance variable? Is because this variable is not marked as static. It's not marked as static. We have just declared this variable the normal way we declare variables, but we have declared it inside a class, not inside a method. So this is an instance variable. It's marked as private. So because it's private, it means that other classes, even though they can be able to access employee, they cannot access ID number. Now, if we want to provide access to ID number, normally we wouldn't want other classes to be able to modify the ID number of an employee, but they might need to be able to read the ID number of an employee so that they know what ID number a particular employee has. So in that case, we provide what's known as a getter. And ideally, the naming of getters, the naming convention is that we start with the keyword get, and then we indicate the variable that's being gotten or that's being read. So we have a method public int get ID. This will return the value contained in ID number. So any class that would want to access employees ID number, it can access it by invoking the method get ID, and then it will return the ID number. Then we can also provide what's called a setter. So with a setter, we provide a setter where we would want to provide a means of setting a value to a particular variable. So in this case, we started with a getter, which was for reading only. And now we move on to a setter, which allows other classes to be able to modify. So it's up to the programmer to decide whether you want to provide setters or you just want to provide getters. It depends on the scenario that you are working on. So if you want to provide a setter, how do we allow other classes to set a value to ID number? How we do so is we provide what's called a setter. It's a method which also is public. Like I said, ideally our methods should be public. Now, setters retain nothing because we are using them to set a value, not to read a value. We are using them to write a value, so they retain nothing. And then the naming convention is that we start with set, and so we have set ID, and then we pass an argument. So we need a parameter here, which specifies what has to be set to the value that we want, to the variable that we want this setter to modify. So we have int ID here. So this, we are going to take the value passed to this method, which is ID, and then we store it in the instance variable ID number. So that's how a setter works. Okay. So that's how a setter works. So in this case, we have provided a getter and a setter for ID number. We have provided a mechanism, we have provided a means through which other classes can read the ID number and write to the ID number as well. So these are called getters and setters. This is again a similar concept that you'll find in Java, though here we can also use what are known as properties in C# to do the same thing, to get a value as well as to set a value. Then let's look at how we declare objects. Okay, so to declare objects, we basically have to do two things. We need to create a variable that will store the object, and then we create the object by using the keyword new, and then we invoke the constructor of the object. So let's suppose, for instance, if we look at this class called employee, for us to create an object of employee, this is how we would go about it. The first thing is, remember, a class is a user-defined data type. So we have class as being as a data type in this case. And then we have a reference variable, which you are referring to as my assistance. In this case, it could be any other identifier, any other legal identifier that you can think of. Okay. And then we now use the keyword new, and then we write the name of the class followed by brackets. So what we are actually doing here is we are invoking what is called a constructor. Okay. We are invoking what is called a constructor. We will talk about constructors in a moment. So this part is the one that creates a new object. So the object is created here, and the object is being referenced by this variable. Please take note that the variable, the object is not my assistant. My assistant is not the object, but my assistant is a reference variable that is referring to the object that we created here. So once you do this, this is where now memory will be allocated to the object. When you create an object, that's when memory is allocated. When you create a class, the compiler does not allocate memory when you create a class, but when you create an object, that's when memory will be allocated for that particular object. Then, so like I said, when we have multiple classes that we have running, those multiple classes should then have at least one class with the main method in which we are going to invoke the methods of the other classes so that they can be executed. Okay. So when it comes to organizing your class, as we have seen, for a class, we have fields, we have methods. So we need a way of organizing your class in a manner that makes it easier to follow through, in a manner that makes it easier and logical to keep track of your code. Because as you write huge projects, you might realize that you end up having so many variables, you end up having so many methods. So it would be easier for you to find some logical way of representing it, some orderly manner for you to represent your class so that it becomes easier to follow through your code. So you can arrange them alphabetically. You can arrange them by sets and gets. Remember, we talked about setters and getters. So you can arrange by sets and gets, and then you can pair your sets and gets. Like if you have a set for a particular field, then it gets followed by a get. Or you can say, I'm going to start with the sets only, and then when I'm done with the sets, I'm then going to get to the gets, something like that. But you should do it in a manner that makes it easier to follow through. So for instance, let's look at the class that I have here. Let's look at the class that I have here. I have a class called employee, and then I have private data members. So I have private int ID number, last name, first name, as well as the salary. As you can see, these are all instance variables, and they have been placed at the same place. Okay. They are on a particular section of their own. Then I can now have a get ID method to return the ID number. So this is a get, and then I have another get last name method which returns. I also have a get last name which returns the last name. So when you look at this, I started with, this, when you look at this code, it starts with the data fields followed by the gets or the getters. We have a get ID, we have a get last name, and then we can also have a get first name, a get salary, etc. And then from there, we then move on to set, where we then have set ID, set last name, set first name, and then set salary. Alternatively, you can do it this way. After you have your variables, and then when you have a get ID, you can then follow it by a set ID. And then when you have a get last name, and then you can then follow it by a set last name, then you have a get first name, then you follow it by a set first name, then you have a get salary, and then you follow it by a set salary. So in any way, you have to do it in a way that makes it easier for your code to, that makes your code easier to follow. Okay. So that's one way of organizing classes. As you can also see here, we have comments. So we also need comments to make the code readable. Okay. We need the comments to make it easier for other programmers to follow through what we have been writing. Okay. So we The private fields or the private fields public method arrangement, it ensures that data will be used and changed only in ways provided in your methods. When you make your fields private, and if you decide that there's a certain field that you don't want modified, it means you are not going to provide a setter for that method. You are not going to provide a setter to allow other classes to modify the value. But if you feel like you need to allow other classes to modify the value, then you can provide a setter. So it's a matter of providing access to say, do you want other classes to have read-only access, or do you want other classes to have read and write access? Okay, so although it is easier to declare fields as public, doing so is considered poor object-oriented programming design. And if you do it in this particular module, you are going to lose marks for that, because I'm here to teach you the right way of doing things. So if you do it any other way, if you think that it's easier for you to declare variables as public so that you don't use getters and setters, or so that you don't use properties, you are going to fail as a result. So let's do things the right way. Let's do things the proper way from the beginning. Data should always be hidden when possible, and access should be controlled by well-designed methods. So take note, I said that there are instances where we might not need to make fields private, like where inheritance is involved, but never in any case are we expected to mark the fields as public. Even where inheritance is involved, you know what modifiers allow us to have certain properties being inherited by the subclasses, or certain fields being inherited by the subclasses. But we must never use classes as, we must never mark variables as public. So let's look at this example of a class which is poorly designed. We have two classes here. We have a class called desk, and then we have a class called testbook. So this class called desk, it has two instance variables, both of which are public. And then this class, which is let me just call it the driver class, which is the main method. It's creating an object of desk. As you can see here, it's creating an object of desk. And then it goes on to modify the value of desk by specifying a value here. It's modifying the value of wood. And then it's specifying again the value of drawers. Right. So notice that wood and drawers are accessed directly from a different class, and this is poor programming. This is poor object-oriented programming. A class must not be able to directly access the fields or the instance variables of another class. This is poor programming. We should be able to do this by providing the getters and setters. Okay. Then so if we then do it the right way, where we are using getters and setters and we mark the fields as public. By the way, before I proceed, let me talk about here. If you mark the fields as public, there's no need for you to provide getters and setters, because these can still be directly accessed from outside. So you only need getters and setters when your fields are not public, when your fields are private, as we can see here. So here we have a class called carpet, and then we have a variable which is constant, right? So if you look at this variable, it's public, but again, it's public and it's constant. So this is constant. Even though we make it public, it also means that the compiler will not allow the value of motor to be modified because it's const. Yeah. Take note of that. It's const, therefore it cannot be modified, whether in the same class or in any other class, even though other classes can access it. So in other words, the other classes, even though they can access motor, they can only read from motor. They cannot modify motor because motor has been marked as const. However, when you look at the other fields that are here, length, width, area, these ones are all private. Now, because they are private, it means for other classes to be able to read from these variables, we need to provide getters. Okay, so then you have get length, and then we have get width, and then we have get area. Now, remember, whenever you use the method get, it must return a value. The value returned should be the same as, the data type of the value returned should be the same as the value actually being returned. In this case, get length is returning length and the data type of length is int. So this method must return an int, and then we return length, which is this one. And the same here, get width is returning the width, which is of type int. So its return type is going to be int, and then we return width, the same as this one, right? And then for this method, as you can see, this method is only providing getters. There are no setters in this case, but we have a method here which is setting the dimensions. It's not, we are not having a setter for each of these ones, but we have one method which is setting the dimensions. So a method that sets values, its return type is void, because it's not returning a value. We are just writing. So because we want to specify, we want to set a value to each of these ones, we need whatever method is invoking this method to specify the values that are supposed to be stored in these variables. So we have parameters, side 1, side 2, and then we can now set side 1 to length, side 2 to width, and then we can invoke the method to calculate area, and the method to calculate area is here, which simply returns length times width. So it calculates length times width and it stores it in area. In this case, this method is not returning anything. Take note that this method is not returning anything, even though it has calculated something. The reason is, after calculating the area, it's storing area in an instance variable which has been declared here. So that's why it's not having a return type. That's why it's not returning any value. It's as good as this method is a setter, but how is it setting the value to this one? It's setting it by multiplying length by width, which would have been set by the method set dimensions. So again, occasionally there are some instances where you would need to make certain fields public. Like for instance, as we have seen previously there, we have a public field, but it's constant. So it means that one, it's not going to change. So it doesn't mean it's not bad if we make it public, because the compiler will not allow its value to be changed by any other classes. So we can, when we have constants, we can mark them as public. Again, a named constant within a class is always static, right? I want you to take note of this point. A constant within a class is always static. As a result, C# does not allow you to use both words, static and const. Okay, you cannot create a variable in C#. I know in Java you can write something like static final. In Java you can write something like static final, and then you specify maybe int and whatever x, and then you specify the value. You can do this in Java where you combine static and final. Now remember, final it's the same as const in C#, because this makes a variable unchangeable. However, in C# you cannot have static and then const. You cannot do something like static and then followed by const. This will give an error, because a constant in C# it's inherently static, and C# does not allow you to use both of them. So take note of that. You might get an error. You will get an error if you try to do that. Okay. Then we can also use the variable, the reference word called this. Right. Ideally, when you have your setters, it makes sense for you, and it makes it more readable and easier if the parameter that you write here has the same name as the instance variable that you want to set. So in that case, for you to use, for the compiler to know which one is which between the local variable that we'll be having here and the instance variable here, we then use the keyword this. We'll talk about this one on the next slide. But let's look at this one, the one that we have right now. we have instance variables that we have there, and then we have a setter right here. So in this case, this setter is going to set num pages, but then for it to set num pages, we need a parameter which is pages. Now pages is different from num pages, so you can just write num pages and the compiler will know that num pages is this one, and then pages is this local variable that we have here. Right? So there's no need for you to use this in this case. You can still go ahead and use it, but it's not a must for you to use it. But let's look at it from a different, okay. So like I said, you can use this here, but then let's look at it from something like this one. Let's look at this example. We have num pages, which is part of our class, or which is an instance variable. And then we have num pages, which is a local variable here. So for the compiler to know which one is num pages, like when you write something like num pages and then you initialize it, and then you assign it to num pages, the compiler needs to know which one is num pages. Are you referring to, is this num pages referring to this local num pages, or is this num pages referring to the instance num pages? So for you to make that distinction, you have to explicitly indicate which one is the reference, which one is the instance variable and which one is the local variable. So the instance variable, we prefix it with this and then dot, then we write the name of the instance variable. So when you write this dot num pages and then num pages here, what it means is the num pages that we have here is an instance variable, and the num pages that we have here is this local variable. So that's how you do it. Okay. Then, all right, I think for now, let me stop, and then I'll have another short video starting from here, which will then focus on constructors, just for the purpose of trying to make this video not too long. I think let me stop here. Let's meet in the next video. Thank you.